Alright, so by now I've actually figured out the entire circuit and how to get it to light sequentially, but I figured I'd go through and actually show what I did to just the circuit itself, minus all the extra stuff that I'll be adding. It actually wasn't all too complicated. You can see I have some extra wires just floating around here for now, but that'll be all connected once I solder everything together to my new little circuit board. But I sort of made a little illustration of what needs done just to make it a little bit easier to explain the changes I made. The main idea of what I did, there are two sets of LEDs by how they're controlled. You have these three on this side, these three on this side. They're actually controlled by this little black guy here. If I can get it won't even focus. But this one's Q4, the other one's Q6, and I believe it's they're either transistors or MOSFETs. And the IC chip right here by the tip of my thumb controls power that goes to a resistor here and here, and those actually control the ground that goes through the LEDs. So if you have them on full or if you have the tail lights on, then they'll be dimmer, but that's actually what controls it. So that's what I'm taking advantage to be able to actually control this. The problems I ran into were the indication for the car. Like if this taillight were to ever go out for any reason, the car would sense it, it would say taillight out, and it would do that fast flicker thing. And it was a real pain to get around that, but I did find a little hack to take care of that. But so my illustration, the first thing you have to do is on the half ring, break controlling connections for the two 5101 resistors. They're labeled R25 and R26. And this makes it a little bit easier to tell. You have the MOSFET Q4 on top of the right hand tail light, and a connection runs from that pin to the resistor. Then you go from the resistor to a little point, and then the chase on the back goes to the controlling IC chip. So I'm telling you to break this connection between here, and the same thing goes for the opposite side. If you look at Q6 is here. It's connected to R26, and R26 has a chase that goes all the way around the back side here to the IC chip. So you have to break the connection from here to the IC and from here to the IC. And this allows you to control this set of lights and this set of lights. And just to show you what I did, it's a little hard to see, but see the little like gash in between there. The yellow stuff is from soldering, but there's like a little gash right there at the tip of my thumbnail. I actually used a Dremel engraver bit, and it has like a little round head, and it's about the finest one I could find before for doing engraving stuff. But I just used this on a low speed and ate away the chase until it was actually broken. And you can do conductive tests with one of these voltmeters just to make sure you have it totally broken. So that's for one side, and the other side was right underneath this orange wire here. There's just a pin here to here, and I broke the connection between there. So after doing that, you actually break the control power to these MOSFETs or transistors, and the LEDs won't be able to light. And the unfortunate part about that is these MOSFETs also tell the circuit that it's lighting, so that's where you run into the indication issue. But before we get to that, the next thing I did, I soldered wiring to the bottom, broken connections. This will give control over the LEDs. So this is more of a schematic view of what I did. You can see R25 and R26 here, and from here they go to the MOSFETs, but you can see after breaking the connections to the two IC chips, I soldered a wire to where the IC chip connection comes out, so that way this can go to my circuit and I can control this power. And then I have a connection coming from my circuit after I control it to the one resistor, and then I run a jumper between one resistor to the other. So that way I use the power from the IC chip and reapply it whenever I want it to light. Okay, after looking at this, I'll show you the wires on the actual circuit board. So flip this over here, and You can see the cut marks here and here. The wire from the IC chip that I'm actually pulling power from to control the half ring is actually this green wire here. So the little solder point that I put onto here is actually on the end of this IC chip here. So whenever the IC chip tells the half ring to light up, it'll go through this green wire to my circuit. And then this brown wire comes into the other end where this pin originally went to before I broke it. So after the green wire comes out and my circuit tells the half ring to light up, it'll put power back through to where the brown wire comes in, and then instead of running additional leads for a second set of wires, I just ran a jumper from here to the other side, so that way both half rings light up whenever the circuit lights the half ring. So that's why you see orange wire going from here to here on the other side of this broken connection here. So the next part of the modification, we actually had to solder a jumper from the half ring to the full ring. And this is the first step of actually fooling the car into thinking that the taillight is still operating properly. So all you have to do is solder a wire from the full ring, or from a full ring regulator output to one on the half ring. This tricks the car to think all the LEDs are lighting properly. So I show on the half ring and the full ring side, you'll be looking for Q4, which is another one of those transistors or MOSFETs, and the other resistor is R13, which is a 2R2 upside down as I show it. So Q4 on here, I honestly can't remember where that is. Oh, yeah, Q4 is actually up here. So it's the same MOSFET or transistor, it's just on the other side of it. So you want to solder a wire between this pin and this pin of the resistor, and you can see this white wire coming off of here. That's what I have here, and it goes to the full ring side to Q2 and R2. So I sort of laced it in through here, and you can see it kind of just tucks up through the back here and goes to, right here's Q2 and R2. So just find the chase between Q2 and R2 and solder it on there. And basically this is just stealing power from this side and making the circuit think that it's allowing ground through here whenever it's actually not. And then after doing that, you have to solder a jumper wire from a half ring regulator to the full ring ground. When the circuit detects that the LEDs are not lit when powered by the turn signal, it tells the car and cuts the power to all the LEDs. Grounding this pin prevents that. So pretty much if any of these LEDs stop working, there's a little circuit on here that makes the entire LED, or the entire circuit, not even light. And I was just messing around trying to ground different pins and stuff like that and actually figure this out. But there's a little, I think this is actually a simple transistor because it has one AM on it, but it's number Q8. And on the circuit, it's really hard to see, but it's actually this little guy right here in the middle of the tip of my finger. And I just drew how the pins are located, so it would be on the side with two of them on the bottom part, as you can see here. And I actually soldered to the back side of it where that's located, so that's where this blue wire is coming. So the blue wire here runs from this 1A all the way through here and goes to the ground pin, which should be P1. Yeah, yes, it goes to P1 on top of here. And then that pretty much will allow you to control the half ring as you need to with the green and brown wires from the IC chip. And then just the remaining connections that I have to interface the delay circuit, I soldered to the full ring P1 to get ground to my circuit. So that same connection that we soldered that little jumper to, we'll run another one off of there to the to my circuit board, which is actually this white wire coming out of this side here. And then I come from the full ring P3, which is the stop power, and I believe, yeah, it's this other green wire here, and full ring P4, which is the turn signal. So I have the turn signal, the brake, and the ground coming from the full ring, and then the control wires that I'll be dealing with. And there actually is one more too. From the half ring, I came from pin 4, which is the tail light, and that's this little orange wire here. So looking from the back, it's like the third one over. Looking from the front, you can see, or hardly see, there's number 4 there. And one thing I noticed between the left hand and right, it would be pin 6 for the left hand taillight circuit. So that's pretty much it. I already have the circuit kind of soldered together. I just need to cut these wires down and makeshift them into here, and hopefully it all works out fine. But yeah, we'll see how it all turns out once I get it all soldered up. It is very, very complicated. It took a good while to actually figure out all these little tricks to get it to actually function properly. But I'm definitely hoping it actually works out good. So we'll see.